Hi there, my name is Kolja Singhvi, and I developed an AI model to predict prediabetes. I call it DPredict, which stands for Diabetes Predict, an artificial intelligence model to predict the likelihood of early diabetes. Here is my abstract. As you can see, I want my AI model to be accurate and at no cost, so the whole world can use it. Here is my research question. Now let's see why I chose this topic. Here are some fast facts about prediabetes. Yes, 1 in 3 American adults have prediabetes. And here are some other reasons why it's a dangerous disease. But according to the CDC in 2021, prediabetes can become prevented diabetes by adding cardio to your daily basis, changing your diet, and altering your lifestyle so you can prevent prediabetes from becoming type 2 diabetes and other things. So the CDC is the leader in health in the world. Here are its current guidelines on if you have a high risk of having prediabetes, which is a little bit different than what I'm doing because I'm doing if you have prediabetes, and then others can also do if you have type 2 diabetes. So here are their current guidelines, and here's their risk test and scoring for prediabetes. So I did a fixed choice one, and it says I have a 50% chance at being at high risk for prediabetes, which means I have a 50% chance of being at a high risk for a dangerous disease, or for 50% chance I don't have it. So here are my hypotheses and outcome for my model. So 1, machine learning, part of AI, can help in creating a model that will allow prediabetes prediction using behavioral and physical attributes. So why artificial intelligence? Because it resembles the human brain in thinking, and it's more accurate than just normal statistics. And why behavioral and physical attributes? Because 50% of prediabetes cases are asymptomatic. 2, different machine learning models will give different levels of accuracy. 3, it is possible to predict prediabetes with greater than 90% accuracy based on available data. And 4, the model can be used to predict early stage diabetes by anyone in the world without any laboratory test on a smartphone. So here are prediabetes symptoms according to the Mayo Clinic, Dr. Mera and others, the CDC, endocrineweb.com, and Community in 2019. The ones that are in red are ones I have not found on any other sites to be listed as prediabetes symptoms. Here are the current AI models and their accuracy. They're from different places in the world, like South Korea and Canada. But as you can see, none of the models go over 90%, and when I looked into them, I realized why. Because they have between 900 and 1,600 different parameters. One of them that apparently was in one was the length of a leg. So, my data is from the UC Irvine Machine Learning Repository. It was collected in Sylhet, Bangladesh, and was approved by a doctor very recently in the summer of 2020. Sylhet, Bangladesh has a population of about 516,000 and has 17 attributes or parameters. Here they are. The ones that are in red are ones I have not found to be symptoms on any other sites, like fungal infections or alopecia. Here is an age distribution graph or bell curve. I did this because I wanted to see if my data was skewed in one way or the other, but it resembles a normal bell curve. Here is a data insight on understanding the data. Basically, all 520 of the patients or study years in this example were asked to select yes or no on if they had things like polyuria or genital thrush. Now here are how the positive attributes, which means that they had it, were distributed by gender. So more males were in the studies than females. Polyuria, both male and female had about the exact same amount. Male had more itching. But like I said, there's more males than females in the study. So for instance, if 2 males had gender, but they had polyuria, but there was 10 males, but 2 females had polyuria, but there's only 5 of them, then you could say that they're equal. But overall, it's a 20% chance versus a 40% chance. So I made this one, which is based on percentages or ratios to each other. And it definitely looks a little bit different. So here's how the males had the attributes. They had a higher amount in weakness, itching, and alopecia. And here's how the females did. Now, some things like alopecia would not be as high in females because of genetics, Now here are the machine learning models I used. All models were implemented using Google Colaboratory, Python, and sklearn. So here was my procedure. I'm going to highlight step 4, which is very important for the end. So I analyzed the dataset in Python and then prepared the dataset for machine learning. So I started with a 90-10 split between training and testing data and progressed to 40-60 between them. To do this, so I split my data into two groups, training data and testing data. Training data trains the model, and testing data validates the model. Here are the results in discussion of my project. All graphs and images in this presentation were made by me. Here is the correlation matrix or heat map. The lighter a rectangle is means the more correlated the 2 points are. If it's in the magenta maroon category, it means that they're not correlated, and if they're in the black, it means that they're negatively correlated. Here it says polydipsia and polyuria, where light orange just means that they're very correlated, which would make sense. It's the increase in thirst, the increase in urine produced. On the contrary, alopecia and partial paralysis are not very correlated, which would make sense since it's the partial paralysis and the loss of hair. So now this is the training data set results. The closer to 100 it is means the better it is. And several neared that, like the random forest model, decision tree classifier. But what matters the most is the testing data set results. And the winner of that was the random forest model at about 98.4%. Second place was the gradient boosting classifier at about 97.9%. Which is actually very interesting because generally a random forest model is it's a group of decision tree classifiers, and it's more accurate than an SVC, but less accurate than a gradient boosting classifier unless given a specific set of data, which it looks like it was in this case. Now, for contribution factors, the top feature derived by random forest was polyuria, polydipsia, gender, age, and sudden weight loss, with irritability, partial paralysis, and alopecia not too far behind. But then I did a reduced parameter model with just these 8 parameters. And random forest was still the most accurate, near perfection in the random forest model, and was the highest in the testing data at a 50-50 data split. Just contribution factors between these 8. Just some differences. Now age contributes the second most when it used to be polydipsia. Age now matters more than polydipsia and gender, and partial paralysis contributes more than irritability in this specific data set. So in conclusion, the machine learning was able to create a model to predict prediabetes with greater than 90% accuracy. It worked well even if it was just 8 parameters, and even if the data was split 50-50 between training and testing data sets. The random forest model was the most accurate model, and among the attributes, polyuria, polydipsia, gender, age, and sudden weight loss were the top 5 parameters for predicting prediabetes at over 70% of contribution. And simple web-based or Android iPhone app will predict the results in less than a minute. In the future, I want to try to model with even a smaller number of parameters, like 6, but sometimes those parameters that are down there, but they still help with the accuracy, and eventually it could get it to 100 with just a smaller number of parameters, but also with a larger number. And I can get more data from a more diverse population, like the USA, or other places where like Scandinavia, Africa. But it must be approved by a doctor. And I want to create an app to allow people to volunteer to take the assessment and compare it with the model results. I'll start with all 17 parameters and then reduce the model inputs based on the results. Here's the bibliography of my project. Now here's the source code of my project. I'll just scroll through and give you a good look at it. I want to thank you for giving me your attention and time. I'm Cool Singvi, checking out.